Next we will continue one more video that is called chemical properties of alkane. There are various chemical properties are there. We will discuss one by one. Okay, the first one is actually alkenes which can undergo electrophilic substitution reaction. Alkanes are extremely stable and inert molecules, and these are inactive towards acids, bases, and as well as oxidizing agents and reducing agents. Okay, alkanes does not react with acids, bases, even oxidizing agents and as well as reducing agents. It can undergo substitution reaction. What is substitution reaction? The reaction in which an atom or group of atoms replaced by another atom or group of atoms are called substitution reaction. The reaction in which an atom or group of atoms replaced by another atom or group of atoms are called substitution reaction. Okay, now I am taking first example here, halogenation. Halogenation means adding of halogen to the alkane. Okay, halogens like fluoro, bromo, iodo. Now I am taking here chlorination. If the fluorine is involving in the substitution reaction, that is called fluorination. Chlorine is involving in the substitution reaction, chlorination. Bromine is involving in the substitution reaction, bromination. Iodine is involving in the substitution reaction, iodination. Okay, here example you can observe. Okay, this is the methane. Is react with chlorine in the presence of sunlight or dark light, or if you take UV light, anyone, either H nu, sunlight or UV light, or in the presence of dark at high temperatures, either 573 to 773. Temperature is 573 Kelvin to 773 Kelvin temperature, which can be converted into here CH3Cl, removal of hydrogen. Then it is again react with Cl2 gas. Removing of hydrochloric acid means here one hydrogen, one chlorine is replaced. CH2Cl2 again is treated with chlorine gas. Removing of hydrochloric acid. CHCl3 again react with the chlorine in the presence of sunlight only. Here also in the presence of sunlight to form CCl4. You can observe methane can be converted into carbon tetrachloride. The reaction in which an atom or group of atoms replaced by another atom or group of atom is called substitution reaction. Here in this during halogenation, mixture of halogen derivatives are formed. The order of reactivity halogens with alkanes. The order of reactivity of alkanes with halogen, that order is fluorine is greater than, bromine is greater than, fluorine is greater than, chlorine is greater than, bromine is greater than iodine. The order of reactivity of hydrogen in alkanes with hydrogens. Okay, tertiary hydrocarbons, secondary greater than primary hydrocarbon or secondary carbon. Primary, tertiary, secondary, primary. This is the first one. Here fluorination is accompanied by explosion reactions, especially fluorine is involved in the explosive reaction, but it is a most reactive halogen. Hence fluorine gas is diluted with inert gas is used as during the reaction. Iodination is a very slow reaction and reversible because HI is formed, means here methane is reacted with iodine to form CH3I, methyl iodide, and as well as a HI. HI means iodic acid, so simply hydrogen iodide. Okay, this Hi is react with in case the nitric acid or iodoic acid. Hi react with HiO3 to form hydrogen iodide can be converted into iodine gas to form here iodine plus water. Hydrogen iodide can be converted into iodine by using of strong oxidizing agents like HNO3 or HiO3 to balance the chemical equation 5Hi. Here 3I2 3H2. In case Hi is react with nitric acid, these are the strong oxidizing agents to form I2 plus water. Okay, balance the chemical equation here. You can observe, and also along with nitrogen gas, nitrogen dioxide gas, NO2 gas, 2 NO2 2H2O, total 2 nitrogens, iodines 2. Okay, this is information about hydrogen iode can be converted into iodine gas. And what is the mechanism involving in the halogenation, sir? There are 3 steps are involved: chain initiation, chain termination, chain propagation. Mechanism. Step number 1, chain initiation. Chain initiation means the molecule split into its free radical. Homolytic cleavage of chlorine undergoes homolytic cleavage and forms chlorine free radicals. That means here, okay, this is a chlorine molecule. The bond may break in such a way, each fragment can take away 1 electron from the bond to form two chloride free radicals. And second method is chain propagation. Chain propagation means if the neutral molecule combines with the free radical to form another new neutral molecule and as well as a free radical. For example, now I am taking here, it is a neutral molecule methane, chlorine is a free radical, chlorine free radical, to form a neutral molecule here, CH3 free radical means methyl free radical and hydrochloric acid. Or if you take one more example, in this methyl free radical react with chlorine gas to form methyl chloride, new neutral molecule form. So take one free radical. In this methyl free radical react with chlorine gas to form methyl chloride and another new free radical, Cl free radical. This is the second one. Third one is chain termination. Chain termination means here simply chain initiation means neutral molecule can be split into free radical. Chain propagation means when the free radical is react with the neutral molecule to form another new free radical and as well as a new neutral molecule. Chain termination means simply these free radicals are combined to form a neutral molecules, new neutral molecule. That is, if you take two methyl free radicals are combined to form a ethane molecule, or methyl free radical and Cl free radical both are combined to form methyl chloride, or two chlorine free radicals are combined to form chlorine molecule. This is the mechanism of halogenation. Mechanism of halogenation reaction, especially chlorination reaction. Thank you. Next, we will continue one more chemical property here, that is And second chemical property is combustion reaction. Another one is combustion. Combustion means when a carbon and its materials, means especially alkane, combustion reaction. Combustion means here when alkanes when alkane burns with excess of oxygen to give heat and light along with carbon dioxide is called combustion reaction. For example, now I am taking general formula of alkane CnH2n plus 2 burns with oxygen 3n plus 2 by 2, 3n plus 1 by 2 moles of oxygen, means excess of oxygen, to form water molecule, carbon dioxide along with heat energy. Here n moles of water molecules, n plus 1 moles of carbon dioxide. It is highly exothermic reaction. For example, now I am taking simple alkene CH4 methane and burning with excess of oxygen to form carbon dioxide, water along with heat energy. That is 890 kilojoule per mole. 890 kilojoule per mole heat energy is liberated. H2. In case a combustion insufficient amount of, this is excess of oxygen. In case insufficient of oxygen, methane combustion with insufficient amount of air or oxygen, alkane forms can be converted into carbon black. Insufficient oxygen to form carbon black and as well as a H2O. Okay, this carbon black carbon or carbon black, this carbon black is useful for the carbon black is used in the manufacture of printer ink. Carbon black is useful for the manufacture of printer ink, and as well as it is useful for the filters, etc. This is information about second chemical property. Third one is third chemical property is controlled oxidation. What is oxidation? Addition of oxygen or removal of hydrogen is called oxidation. Here, okay, the two gases like methane and oxygen gas is passes through the copper tube at 523 Kelvin. Methane gets oxidized into methanol. Here CH4 methane gas and oxygen gas. On passing of these two gases through the copper tube at 523 Kelvin temperature, this can be converted into methanol. It is also called methanol. That means CH3COH, methyl alcohol, or simply methanol. And passing of methane and oxygen gas to the copper tube with 523 Kelvin, methane gets converted into methanol. To balance the chemical equation here, there are two oxygen atoms are there, 8 hydrogens, balanced. And one more point here, on mixture of a mixture of methane and oxygen when passed over heated molybdenum oxide. Okay, mixture of methane and oxygen. A mixture of methane and oxygen is when passed over heated molybdenum oxide. Molybdenum oxide means MO2O3, dimolybdenum trioxide. And it can be converted into, it can be oxidized into, okay, on passing of mixture of methane and oxygen gas to the molybdenum oxide, it can be oxidized to methanol and as well as a water. This is called methanol or formaldehyde. Okay, one more when ethane when oxidizes to in the presence of manganese acetate to form a ethanoic acid. When ethane get oxidizes to oxygen in the presence of CH3COO taken twice Mn, manganese acetate, in the presence of manganese acetate to form ethanoic acid. Ethanoic acid means CH3COOH and as well as water to balance the chemical equation here. 2C2H6 balanced. Here 3O2. Like that, these are all controlled oxidation. I hope it is clear. When alkanes are resistant towards oxidizing agents, but alkanes of type of tertiary alkanes means tertiary butyl can be converted into alcohol. Sometimes here you can observe that. Now I am taking tertiary butyl butane CH3H oxidation in the presence of KMnO4, the presence of alkaline KMnO4, it can be converted into CH3OH. This is called this is a tertiary alkane converted into tertiary alcohol, tertiary butanol. It is also one more chemical property, controlled oxidation. And another chemical property is isomerization. Isomerization means it is unheating with N-alkanes unheating with anhydrous aluminum chloride or HCl to form a branched chain, normal chain. N-alkanes, normal straight chains can be converted into branched chains. Branched chains on heating in the presence of AlCl3 or HCl. For example, now I am taking pentane CH3, CH2, 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 CH3, N-pentane in the presence of AlCl3 or HCl to produce, it is a two types of products are obtained, that is isobutane 1 2 3 4 5, isopentane and as well as another product neopentane. Neopentane, two types of products. Simply N-pentane can be converted into isopentane and neopentane. If you take butane CH3, CH2, CH2, CH3, it can be converted into in the presence of AlCl3 or HCl. Here temperature is 200 degrees Celsius. At 200 degrees Celsius at 35 atm to form CH3, 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 isobutane. These are the example for isomerization. And another one is aromatization. or it is also called aromatization, also catalytic reforming, the conversion of aliphatic compound into aromatic compound in the presence of vanadium oxide or molybdenum oxide or chromium oxide, etc. For example, now I am taking here CH3, CH2, 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 1, 2, 3, 4, 4, 5, 6, 6-member ring in the presence of chromium trioxide, or if you take molybdenum oxide or vanadium oxide, can be converted into 773 Kelvin benzene. It can be converted into benzene. Means aliphatic compound converted into aromatic. If you take a 7-member ring, CH3, CH2, 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 CH3, 1, 2, 3, 4, 5, 6, 7. It also can be converted into aromatic compound like toluene. Toluene means methyl benzene, or it is also called toluene. Aliphatic compounds converted into aromatic compounds are called aromatization. And another one is reaction with steam. Reaction with steam means here, okay, on heating of alkanes with higher temperatures, like steam means water. Okay, for example, now I am taking methane, is react with steam in the presence of very high temperature like 1000 degrees Celsius. Nickel act as a catalyst on heating. It is 1000 degrees Celsius. It can be converted into carbon monoxide and hydrogen gas. This is called mixture of carbon monoxide and hydrogen gas is called syngas. And finally, last chemical property is pyrolysis. What is pyrolysis, sir? Pyrolysis means it is a decomposition of higher alkanes into smaller fragments on strong heating in the absence of air. It is called pyrolysis. Means it is also called cracking. Simply decomposition of molecule. If, for example, if you take methane molecule, okay, decomposition of higher alkanes into smaller fragments on strong heating in the absence of air is called pyrolysis. It is also called cracking. Here on heating 1000 degrees Celsius, this methane molecule can be decomposed into carbon and hydrogen gas. One more example, if you take ethane, C2H6 on heating to produce like 450 degrees Celsius temperature, which can be decomposed into CH4 molecule, C2H4 molecule, means ethene molecule, and as well as a hydrogen gas. Okay, the decomposition of higher alkanes into smaller alkanes on heating in the absence of air is called pyrolysis. It is also called cracking. Okay, what are the uses of in this alkanes, sir? Uses, it's very easy points. Okay, CCl4, carbon tetrachloride, is useful for the fire extinguisher. C2Cl6, okay, it is also useful for the preparation of artificial camphor. And CCl4, carbon tetrachloride, is useful for fire extinguisher. C2Cl6 is useful for manufacture of artificial camphor. And CCl2F2, or if you take CF3, CL, it is useful for the refrigerant in refrigerator and manufacture of aerosol sprays. And also it is useful for CFC11, especially useful for the refrigerant in refrigerators. Refrigerant. This is information about what are the chemical properties and uses of the alkanes. I hope it is clear. Please understand this concept. I hope it is clear. Thank you. Thank you, one and all. We will end the session.